Hello and welcome again to a derp stream. I'll have to see what it becomes this time and how the program will come along. Let's see. Okay, so I'm updating some vertices, it looks like. Yes. So let's try and run this. Now I made one edit, and that is to have all floors, just for testing, because I think there might have been some weird stuff going on. And still ray index out of range. So why? It's the, let's see, ray index out of range, which means that we've set an update at something that we cannot update. It's not good. Oh yes, we have set the index at a bad location. So maybe something went wrong here. Let's see. This looks alright, this looks alright, this looks alright to me, and so I'm not sure exactly what's wrong, which I wasn't before either, which is why I quit. Basically rage quit, but coding rage quit. So let's try and solve this conundrum once and for all. So the problem is that the coordinate that we're getting here, these are not inside the space, which is bad. So let's log some stuff and log the vchord.x plus vchord.y, and I would probably like for it to be minus vert left, minus vert y, vert bottom. There we go. So now we can see some more debug info about it. So it's minus 20, which is strange. So the x value was alright, I think. So the, right, we need to check the size. It's 30. So the x value wasn't correct either. None of them, neither was alright, which is bad. So let's see our chord y. Let's see here. This thing, we're going to copy that, and I'm going to have just the x and y. Then I also want to copy it once more, but this time just have the bottom. So this thing left and bottom. I however have a theory, but that might be very wrong. So let's get all of this data, see what it tells us. Okay. Indeed. So we have 30 and 60, which, let's see. So it should be 30 to the right, which, so we have 0, 1, 2, 3, so something like here looks like what we want. And we have 60, but it was 80 and 40. So obviously the coordinates aren't correct, and I think I know why. Because as you can see, this 40 would correspond to a 30, and the 80 would correspond to a 60. So my sort of theory is that really, and let's just find the debug log here so I can remove it, so we don't need it anymore. So let's see. We have our let's see, update vertex here. So we have x, y, those aren't mixed up. The vertex chord x, y aren't mixed up. I plus j times sections that with that should be right. Maybe I haven't, in the create mesh, I have put them in the wrong order. Current section plus plus. Yes, it looks like I did. So that's the real issue here. Let's see if I use ij somewhere. Doesn't look like it though. No. Okay. So let's see. Left plus equals section size, bottom equals 0. Right, I think it should really be left equals 0 here, and here it should be bottom plus equals that. Bottom equals 0, and left is undefined. That should work, hopefully. Okay, number overflow. Why do I have it? So it doesn't like this. Word width, word height. Controller. So oh, it's in the mesh controller. Well, now that makes sense. So left and right were wrong. So what were those values? Where are we passing those? Here. So new mesh controller, left, right, bottom, top. Right equals left plus section size plus 1. And here left plus equals section size. Here we want bottom. Okay. that should be alright. Hopefully. Let's see. Indeed. And now we had an infinite loop because it did not crash. Which is nice. So none of this code was actually faulty, it was just my previous code that was. Okay, that seems about right. Let's see what happened. So, at the moment, looks like the parts that are updating, that should be updating, are in fact updating. However, because as you can see, they are going up and down all the time. This looks about right. Also, the FPS are fine, which is good to know that it doesn't completely destroy it at the moment. However, as you can see, this is sort of the problem, is that this vertex is not being updated on this one or this one or this one. So I need to find a way to solve that. But other than that, it seems to be working. So now all I need to do is change this logic. So bottom top equals, let's see, no, top should be calculated first, then bottom equals, top is larger than 0 and top and section vertex coordinate dot y minus top times section size. Now what does this mean? Not entirely sure, so we'll have to try that out. But basically, if that is true, then we want to say top minus 1, otherwise top. So this is going to be really strange sort of logic, but what this is essentially saying, or well, effectively saying, is that if the y-coordinate minus the y-coordinate of the section is 0, that means it's in the bottom. And that means that the bottom should be 1 lower. And this just makes sure that we're not going below the world, so to speak. So let's try that out. See if it works. Let's find the one that was on the edge. This one. And indeed, as you can see, that is working. Now there are two of them that are being updated regularly. So let's add this for the left. So we're just going to do the same sort of logic with the left one. Only that here we're going to use the right instead of top, and we're also going to do x instead of y. That should be pretty much it. So let's try that out. See if it's fully functional now. And indeed it is. So now all of the spikes look perfect, except for obviously the border lines, which are a problem with the shader and not something to be worried with right now. But the FPS have taken a big toll, but I think that's mostly because this is happening every frame. So I think that's fine for now. So yes, that is indeed nice and that's making me happy that that is working like it should work. Now that that's working, we can remove all of this bad code, because that's really annoying. Let's see, like so. That's what we're gonna do. So what are we going to do now? Well, I think I just want to clean up some code here, see sort of what I can improve with it. Then I'll have to figure out what to do next. I can look here at my schedule to see log in. Okay, so here we have my schedule. So tile and vertex data structure, I mean, that's sort of fine. Let's see here. Can I take a look at the timeline? So yes, indeed. So tile requirements. All right. However, right, there was something else I wanted to do before that, and those are, well, that is, I should say. Let's see. What do I want to do the first? Let's see here. Let's see how long this is. Okay, so it's like 260 lines of code. That's pretty, starting to get pretty sort of long rendering code here. But since it's sort of not super important, well, it is super important, but it's not going to be sort of all the time. Right, I'm not going to sort of look back on it that much, I don't think, and it's relatively clean. Could probably be a lot cleaner and a lot better and stuff like that, but I feel like you can read it sort of. Okay, let's move on then. So what do I want to move on to? Well, that is the world data structure. So it's a vertex. My plan is to have a stack of vertex types. Vertex type, because something I want to try just is type dot peak. Okay, so let's take a look here. .NET C# .NET stack. Okay, so I just wanna let's see, stack. So I just want to see what that does and make sure that it peaks on the peak, returns the object on the at the top of the stack without removing it. Okay, perfect. So I can do that. So why would that be good? Well, let's see. Vertex, get vertex. What we want to do now is we want to say dot peak. Well, no. The get vertex is fine. Something that we want to find is here the error list. First, v.type v.type.peak. What we want, type.peak title data. Right, so this one, generation process, is going to have to be a lot more complicated. And I think really what we want is a vertex array. Generate world int width, int height. So we're going to have to do a lot more than before. Obviously, we want to also make sure that in the world generation, the world generator takes generate world the vertex array. This is so that I can make the generators much more extensive and make them multi-step, which in this case the classic world generator is first going to generate a height map. I can just remove all of the code. Vertex array, 0 elements. Generate world. So instead, vertices equals, right, generator dot generate world. So now obviously we want the let's see, how did I do that? Right, vertex width and vertex height. Vertex width, vertex height. Okay. So, game controller hides renderer. Right, maybe. Right, I don't need a renderer for the world, so let's just make a new keyword so that it doesn't care. Okay, good. So we don't want to return a new world of 0. We want to make world.vertex. Let's just use the world. Assets dot scripts dot world, no, using world. Can't I do that? Why? Anyway, okay. World dot vertex array. Vertices equals a new world dot vertex array, and width times height. Okay, so we want to start by generating a height map. So it's going to be an int array called height map. And so we want to make the height map pretty much the same way that we've done everything else so far. Okay, so we can say height map index equals noise, well, maybe math dot math f dot Perlin noise. There we go. And it's going to be the ij, but obviously we need some other things. So the first thing is so the world is going to be added to the water level, and we're going to multiply it by the scale. We're going to divide these by the roughness. Here we go. So that's going to be the general quality of the Perlin noise. Can it convert from float to int? No, you can't. Floor to int. And I'm going to have to move this down to another line. Wasn't even 2 lines. Just to make sure that it's all visible. Okay, so now we've generated our height map. Great. Let's see what we can do with the vertices after that. So at the moment, I don't want to do too much. I just want to do this. So still have index equals 0, and index is less than len. So basically the length, everything. And then we're going to basically say vertices at the index. Well, first we need a stack world dot tile. So this is going to be stack of tile type. No, don't I have that? Vertex type, that's what it is. Vertex type. So you have a stack of vertex types called the vert stack. It's going to be a new stack with vertex type. And we're going to go while vert stack dot count is less than or equal to the height map at index. We're going to basically just push to the vert stack, push a new vertex type dot dirt. Of course, I'm also going to later, right, so let's just do this. So let's say if let's see, vert stack dot count is less than water level, then we're just going to set it to dirt. Else if the vert stack dot count is less than or equal to water level plus 2. So we're going to have a bit of a sort of range. Vert stack dot push vertex type dot sand, and else vert stack dot push vertex type dot grass. And later, of course, we might make some adjustments to this, like replace the grass or dirt with sand if it's close to water or something like that. But for now, this is going to do. And so, alas, let's create the vertex. Vertices at the index was a new world.vertex with the height being the height map, the index, and the type. Well, we don't need the height anymore because we already have that. So all we need to do is just give it all of that data. And that should be in the world here. The vertex. You might still want to have a height, but really all we want is just say the type dot count. And also this should be renamed to the data, or maybe the blocks or something. Okay, so I'm going to just have that, and it's going to just be the vert stack we just created. Okay, let's see if that works. I'm skeptical, but let's see. Yes, it does work. It's just a bit rough. If if I might say so. Yuck, that looks awful. It looks like grass, but it looks not perfectly like grass, really. Okay, I think I get it. It's because it's not supposed to be divided by roughness. Roughness is supposed to be multiplied. That's sort of the conditions that I designed the values for. Okay, that's much better. And it looks like the water level is a bit wrong. It should maybe be added water level minus scale divided by 2 or something. And, you know, maybe that should work better to create the water that we want. Oh. So it was too much. Height map index equals height map index larger equals 0, 1, 0. So basically just making sure that it's not 0, because in that case it's not going to do anything. Index, okay, there we go. Perfect. Let's see if that works now. So we have some operations functional, but let's try dividing by scale divided by 2. I'm not sure if this is going to work that well, but let's see. Because it might, yes, it creates a lot of water, which is nice, but it creates a lot of these sort of planes at the end of the water, which I do not like. Right, as you can see here, this is like a massive plane, and those are created, which isn't perfect. So let's in the game controller, let's add some higher water level, because now it doesn't really matter. So in the classic, let's see the water level. So let's make it up to something like 20, something crazy like that, because ultimately it does not matter. Okay, perfect. And this water plane doesn't follow with the water level, which is sad. Fortunately, that's what happened. So let's try and fix that. So the plane is something on that. It should be at 0. To water, and I'm thinking that really the world should be designed or rendered in the water as a sort of with water in mind. So we take the readword.height minus game world.water level, which means that the water level will be at 0, and I think the really what we want is to get the height of a certain thing. So we want a function for that. So int get height of a tile over a vertex world dot vertex so we get the height of a vertex vert. I also need a game controller and a world w. And so what I'm going to do is just return vert.height minus world.water level. So now you can just use the getHeight function in place of our calculations. It's going to be really handy. let's see. We have our thing right here. No, here we have it. So we have this thing, in which case we're just going to do get height with the read vert and the game world. We're going to do the same thing. Static. Should really be just a public static. Not a public though, because that would be stupid. Static. Which fixes that problem. Good. Update vertex. Vertex update q.enq. So here we have another one of those. And here I need to do the get height once again. So now it's the v game world. Okay. Let's see if this works now. Alright. No. It does not. Which is annoying. So why is that? Game controller is at 0. The world section is at 0y, but the values are not correct. Which is annoying. And I think... Oh! Aha! This is the problem. We need to set our water level. So let's do that. So really, there is no water level. So in this, we really need a generator. Generator dot water. Dot. Oh, the generator does not have a water level. However, I think really the world should have basically the public int offset. The origin. And the origin should be passed in by the generator. So the generator should give us an origin, and that should be important. So we need to have a public int get origin. Turn water level. Because what if we have something that's not a water level? That would be bad. Oh, it's not even abstract. That's kind of funny. Okay, so we have a classic here. We are in fact implementing the get origin. Right? No, we need to do an override. So, origin. So let's go in the world and say that this dot origin equals generator dot get origin. Okay, let's see how that works. Yes, it looks like that's correct. However, the origin should be a float, because it doesn't have to be an integer, to be fair. So let's do that. Float. And so now we're just going to do something like plus 0.5f. Well, plus something really tiny. 2.2 or something. Not too big. Cannot convert it. Tight. Float. No, int. No float. Float will do for my purposes. Cannot. Okay, now you're happy. That is glad making me happy. Okay, so it seems to be working. The world generator seems to be doing okay, which is nice. Thank you very much, world generator. Now we need to have some mining in the game, because mining is fun, and mining we shall have. And all mining will do is mining a tile will basically just pop that tile off, and then we'll update that vertex. So let's do that. So let's okay. Let's just have fun. I want to try something just because it's fun. So what if I make this something really big? Let's try that. Mountainous mountain ranges. Let's generate some fun terrain. Woo! No, that's boring, man. Thought it would be more fun to have a massive scale. Maybe it wasn't massive enough. Let's do something like 60. Something really big. So now it might take a while to generate. But yes, okay. Cool mountains. And the water level is really high, which is bad. Well, not really. I mean, if you have a mountainous area, you kind of want the water level to be really sort of mountain-like as well, don't you? However, maybe I want an area to have some offset in its terrain. So basically we have, let's see, so this might seem counterintuitive, and it probably is, but I think it will be fun. So maybe I should make another map and use sort of different noise maps for different properties. So one noise map might be for, okay, well, let's just explain my thought process. So one noise map might be for generating for the scale of the terrain, and one noise map might be for the sort of total elevation of the terrain, to make it more sort of more variable. One might be for the sort of the stretch of the terrain, and so on, so forth. Well, the stretch of the terrain won't change, but yes, that's sort of the idea. I think that would be cool to do. So let's try that. Possibly. So we have this. And we might add another Perlin noise function. Perlin noise. This might be I times biome delta. So here I get to use for that variable j times biome delta times water level or something crazy like that. So let's just remove that. So let's see how that goes. Now I might make sure that this biome delta is relatively small, because I don't want it to go out of hand. However, yes, indeed, this looks like a fairly neat terrain. However, it's just grass at the moment, but I mean, it looks fairly neat. Yeah. I don't see any sort of height variation yet, so let's, well, any massive height height variation. So let's try even bigger. Let's see sort of if we can find any sort of evidence of this happening. Not yet. Let's try and make this smaller, something like 0. That way we can test this good and nice and well. Let's see. No, then it's completely flat. So it's clearly not doing what I want it to do. So I times biome delta, j times biome delta times water level. So let's add, first of all, like 1,000, well, 100 maybe, that might be enough. And also, let's see, maybe it's too small of a delta, of a change to really make it work. Let's make something like this. That should be really mountainous and so on. And indeed it is. It's just really small mountains, which isn't what I want exactly. So let's see. Probably in the classic one I want to multiply this by something like 6, just to make sure that it's really over the top. Yes, okay, that's perfect. Absolutely perfect. Okay. So now we're just going to crank this down a whole lot, just to make sure that it's really subtle effect, but not too subtle. Yes, this looks perfect. This is just what I want. So we have our massive map with very sort of varying terrain. This, I can't really go here. I'm going inside of the terrain, looks like, which, you know, isn't preferable. Yeah, that's not really what you want to be doing. My good sir, you wanna get to the top, but okay. So now we're going to increase this as well. 0.03. So we're going to have a fairly sort of large thing. Let's see how this goes. Right, and I also need to make sure. Oh, that's the scale of it. It should be much bigger. Okay, that's what we want. Definitely. Yeah, look at that. That's interesting terrain, right? It's really interesting. Let's see. Once again here. Let's make it a bit bigger. the train variation. Okay, so as you can see, we have our mountainous regions and our really sort of top level things. Now I'm thinking as well is that the mountainous regions should be more extreme as we go on in the valleys. So I should probably multiply it by the difference between that and the water level. And also in the classic world generator, I need to subtract. We don't want to add the water level, because the water level, we want to add the water level. We also want to subtract the scale times the water level times 6 times 2 or something crazy like that. And everything is not here. Nothing's there. That's not good. It's like 3 then. So that the thing isn't massive. Still not working. Okay, I think that might be the problem. I'm multiplying them. I really should just be subtracting them from each other. And that looks great. Okay, this is perfect. Although, somehow the water level is being handled the wrong way, I think. But this looks sort of okay, I guess. Yeah, I kind of like this sort of island thing, how it looks and so on. However, I might not want to subtract just as much, but still, islands are cool, and I think I shall keep them like this. Let's make a bigger map, and then I'll end the stream here because I don't want to go too much. So let's do it 2000 by 2000 once again, like I've done in the past. Let's make the camera really big, and let's maximize this window as well after it's generated, which is going to take a while, because otherwise the FPS will take a toll. Let's maximize this. Okay. Yes. Okay. So we have our islands, and they look really cool, according to me. These islands are awesome. So oceans and islands. Then you build on these islands, and you try to take over the other kingdoms on the other islands. Yeah, I'm probably going to keep this world generation as an island sort of game mode, because this generation is awesome. They are fairly long apart, but that fairly far apart. But that might be an interesting sort of way to make sure that you can't just walk over there or swim by hand. You need to actually sort of send boats or whatever to that place. So that might be a cool idea. And then, yeah, we got our islands over here as well. Yeah, it's going to be a really big map if you decide to play on this big. And here's a really big island as well. Ooh. Yes, but indeed, this is starting to come along. At least the world generation bits of it. Not the other parts, not so much, but later I'll start working on actually breaking the world and so on, but not right now. So I feel good about the progress. I fixed the bug, that's good.